Hello, my name is John Bannon. I'm an attorney and philosopher. Today's video, I'm going to discuss superdeterministic correlations bypass quantum randomness. Now, you may hear people say that, well, the universe is chaos or it's random. But is this claim really true? And the answer is yes and no. So I'm going to explain how it comes to be that randomness is not as random as you might think it is. So superdeterminism is defined as a property of any physical theory that produces systematic violations of statistical independence. You can find that definition in the article on measurement, superdeterminism, free will, and contextuality. That's at ARXIV 2604.0031, March 31st, 2026. Now, Hansonian superdeterminism meets this definition by avoiding statistical independence through the use of a static block universe without cause and effect or probabilistic causation in physics. Hansonian superdeterminism is based on the physics proof of Swedish theoretical physicist Dr. Johan Hansen, which you can find in the peer-reviewed physics journal, Physics Essays, volume 33, number 2, June of 2020, pages 216 to 218. So uh, essentially, we live in a Hansonian static block universe, which means we live in 3 dimensions of space and one hidden static dimension of time in a fourth dimensional block universe. And the only thing in this universe, besides nothing, is particles. And the particles are, you can't move them, they're set in place like pebbles in concrete. You can't change them without cause and effect in physics. They're permanent. But these particles do create patterns through the static dimension of time. And we describe those patterns through our mathematical, logical laws of physics. So in our universe, we have inherently random quantum events, such as the spin measurement of an entangled particle, such as an electron, as either up or down spin. And there is a seemingly inherently random 50-50 chance that when you measure the entangled particle, you will get either up or down spin. However, is that truly random? It appears to be truly random. Sure, it's 50-50 chance. But it's not completely random because it is determined by its context in the block universe. In other words, superdeterministic correlations determine what the spin measurement result is going to be. So even seemingly random quantum events are actually determined by their location in a pattern of prior, present, and subsequent events with which it is correlated in the static block universe. Now, superdeterministic correlation is not the result of cause and effect in physics. It's the result of the pattern, the static pattern of particle positions through the dimension of time, which requires a particular value for even an inherently random event because that event is correlated with other predetermined events. So, for example, let's say you have a entangled pair of electrons and you measure the spin of one of those particles, and it appears to be a 50-50 chance, and it turns out that it's up. Well, you know that the other particle measured has to be down because it has to be an exact opposite. That's the correlation. But the fact that the other particle has to be down means, because it's correlated with the other particle, that the other particle has to be up. So the particle's spin is superdeterministically correlated and determined by the other particle, and vice versa. So they both have to fit the value for their location in the patterns created by the static particles in the static block universe. So while they may appear inherently random, they're not actually inherently random. They're determined by the context of their location in space time. So, superdeterministic correlations mean that any event can be determined from the pattern of past, present, or future events correlated with that event in our static block universe. So a quantum event is not really random when taken in the context of the predetermined particle positions under Hansonian superdeterminism. Randomness is only ever a placeholder for missing contextual information about the static block universe, whether those events are in the past, present, or future. So, uh, is it true that there's randomness and chaos in the universe? Yes, but it's not independent of the pattern it's set in the static block based on all the other events in which it's correlated, which determine what it has to be. Even though you think it's random, you only think it's random because you don't know about all the missing contextual patterns that are setting its value. All right, well, I hope you learned something about Hansonian superdeterminism and how it bypasses quantum randomness. I'll give you a second to read the board. All right, until next time, take care.